Hello and Assalamualaikum to Madam Zaina. I am representative from Good Seed, will present about our good project from subject CHE 249 regarding the concept of fish dyeing in separation process. This group consists of 4 members, that is, Mujuddin bin Maslan, Nazrul bin Nazri, Al-Amir bin Sabri. First, I will present about background of fish dyeing in food industry. Fish dyeing is a process that dehydrates frozen foods placed inside a vacuum. The moisture in the foods converts into a gaseous vapor that leaves the food during processing. This removal of water content from frozen food is called sublimation. The fish dyeing process allows the food to keep its original size and shape with minimum cell damage. Shrinkage is therefore eliminated or minimized, and the food remains preserved for long periods in a near-perfect shape. The fish dyeing process is carried out in a special machine called a fish dyer, which has a large chamber for freezing and a vacuum pump for removing moisture. The fish dye process was developed commercially in World War II, when it was used to preserve blood plasma and penicillin for wounded soldiers. Fish dye coffee, which was created in 1938, is the best known fish dye product. Nestle Company invented fresh dyed coffee called Nescafe, and later other powdered food products were fish dyed. Over 400 different types of fish dyed food products have been commercially developed since the 1960s. Although fish dyeing is used to preserve food in the 1970s, agricultural crops such as peanuts and tobacco were also fish dyed. Okay. Steps in the fish dyeing process. First, the food product is first frozen so that a condition can be created for low temperature dyeing. After freezing, the product is placed under a vacuum. This enables the frozen solvent in the product to vaporize without passing through the liquid phase, a process known as sublimation. Third, heat is applied to the frozen product within the vacuum to speed up sublimation or removal of water. And last, low temperature condenser plates remove the vaporized solvent from the vacuum chamber by converting it back to a solid. Process flow diagram of fish dyeing. As shown in the slide, this is the diagram and it is called the fish dyer. There is 4 main components of the fish dyer. There is dyeing chamber, heat source, a vacuum pump, and a condenser. Okay, I will pass for the next presenter.
Role. So I will continue with I will explain a little bit about the process involved in this freeze dryer. So as he said just now, there are 4 components in this freeze dryer, which are drying chamber, vacuum pump, heat source, and also the condenser. So this drying chamber is where the frozen product is placed, although the freezing process can be done within the chamber as a first step. In this case, the equipment must have a freezing system. However, the chamber must be a vacuum-tight design, and the shelf in the interior will require the temperature and also the pressure control. So, for the pressure involved in this equipment it must be about 0.006 atm, and for the heat, this freeze dryer usually operate at low as negative 30 degrees Celsius until 150 degrees Celsius. But the latter might be too high for the actual application in practical application. But but it is essentially determined by the glass transition temperature and the moisture of the content of the food. And finally, for the last component is the condenser. This condenser will collect the water vapor release by the sublimation of ice within the product, and also it must have the sufficient surface and cooling capacity to freeze all the steam generated during the sublimation process. And this water vapor will contact with the condenser surface and will be turned into the ice crystal, which they will release energy afterward, and this crystal will be removed from the system. So let me proceed with the stage of freeze drying. So there will be three stages. First is pre-freezing, and the second will be primary drying, and the last one will be the secondary drying. Okay. For pre-freezing, the first step, the sample material that we put in the freeze dryer will be cooled to the melting point. So this will ensure that the sample will be completely frozen and can undergo the sublimation process. Although if let's say if the sample isn't frozen solid, the evaporation will occur and the sample will not achieve the same preservation properties that occur with the sublimation. This will thus will form the large crystal that will break the cell wall and damage the sample. And then uh, after the sublimation process has been undergoes, then this freeze dryer will proceed to the next step, which is primary drying. So this process will only start when we turn on the freeze dryer and vacuum pump. So this will generate enough heat. No, it will generate enough energy for heat to speed up the pre-freezing process just now. And this will lead to the evaporation, which this evaporation will make the cooling of the sample begin. And during this process, there will be roughly 93% of the water will be sublimated out. And this method usually usually the method will end here, but it is only for the short-term preservation of the sample. It is not suitable for the if you want to store the sample for a long time. That's where the last part will come, which is the secondary drying. The secondary drying is more suitable if we want to make the long-term preservation, and also we want to store the sample for a long time, which we will repeat this pre- previous step, but just now for this step will be adding more heat. More heat will be added, and there will be more water molecule will be released until we leave only 2% of moisture content. And that's all for these three stages. I will pass the next part to the next presenter. Thank you.
Assalamualaikum, and now I will present about the comparison between freeze drying and distillation process. So we will start with definition. For the freeze drying, it is also known as lyophilization or cryodesiccation. It is a low temperature dehydration process that involves freezing the product, lowering pressure, then removing the ice by sublimation. For the distillation process, distillation or classical distillation is the process of separating the component or substances from a liquid mixture by using selective boiling and condensation. The industry that applied this concept for freeze drying is pharmaceutical industry and food industry. For the distillation process, it is oil refining, water purification, and alcoholic beverage production. The advantages for freeze drying is food retain its original form, size, color, taste, texture, and nutrients. And food has a long shelf life at room temperature and does not require a cold storage. For the distillation process, high purity products, economies of scale, well established technology, and competitive supply of equipment. The disadvantages of freeze drying is not all food can be freeze dried. Airtight containers are required for long-term storage. No space savings, which is the food's cellular structure is mostly retained. For the distillation process, more time consuming due to the low pressure of rising steam. And lastly is high energy usage. That's all from our group. Thank you.